Hi everybody, welcome to another video in Trigonometry, section 3.4. This is an application of trigonometry about linear speed and angular speed. So, let's say we have a wheel and there will be a point on the wheel. Let's say if we rotate where the wheel rotates, there will be two speeds that we can talk about. Because with respect to the center of the wheel, it will have the speed of rotation, how fast the wheel turning around the center. At the same time, if we're tracing the point on the circle on the wheel when we rotate, that translates into the speed, how fast the wheel turning going along the horizontal line. So just now when we look when we ride the car, there are two things will be the speed of the car is usually miles per hour, and then another speed is the speed of rotating RPM, RPM, which is revolution per minute. And the angular speed is given by the change of the angle over time, and the velocity or the linear speed is the distance over time. So if an object travels around a circle, radius r, so r is the radius, an object travels through an angle theta radian and an arc length of s, so s is the arc length and time is t as usual. So the speed is distance over time, and the distance this time will be the distance is the arc length, and the angular speed is the angle divided by time. Right. So very straightforward. And finally, s is equal to r times theta. The arc length is equal to the radius times the center angle. So we substitute in that in s is equal to r theta, and then we group theta over t together is omega, and we have v is equal to r omega. Right. By the way, let's go over how we say this thing. So the linear speed v, s, and t, so on the English letter. The angular speed we have theta, and this is not a w, this is omega, a Greek letter. So angular speed we use the Greek letters in the formula, and the linear speed we use the English or the Latin letters, right? And the relation between them is this. The most important thing here is just the unit, and make sure that whatever we use the angle theta, it has to be in radian in our calculation. Yes, I will not emphasize that enough. Theta has to be in radian. Right, now let's just look at some example here. A model plane is attached to a swivel so that it flies in a circular path at the end of a 12-foot wire at the rate of 15 revolutions per minute. Find the angular speed and the linear speed of the plane. Right, so of course again it is fly on a circular path, but I'm going to draw that in 3D, so kind of we can visualize it. So let's just say it travel in a circle, but the circle in 3D should look like an ellipse from our perspective. So an airplane will travel around the circle. Let's see, this is there's a stand and attached to a swivel, so this will be 12 feet, and the airplane this will travel around in the circular path like that. Right, so what do we have? First of all, R is equal to 12 feet. That's easy. Next, we have 15 revolutions per minute. So what is that? Of course, that is RPM. So we have 15, and that actually is going to be the angular speed. 15 RPM, or we mean 15 revolution per minute. We have that. Now, of course, that works, but usually revolution is not a unit that we can calculate, so we prefer to use radian. And this is where we do the conversion factor. Note that 1 revolution is equal to 2 pi radian, right? Now, if we do not want revolution, we're going to put the revolution at the bottom so it will cancel out. And because we put the 1 revolution at the bottom, we have 2 pi radian on the top. And when we do that, revolution cancel out, and we have 15 times 2 pi, so that's 30 pi radian per minute. So that is the angular speed, of course, in radian per minute. Angular speed. Right, now, so we have the angular speed. Now, how do we find the linear speed? Of course, the relation of the two is this. So the radius is 12 feet. The angular speed, 30 pi radian per minute. On the previous section, we did say radian is a special unit. If we don't want it, we can take it out. If we want it, we can put it in. It doesn't matter. So it cancels by itself. We have 30 pi times 12. 30 pi times 12. 30 times 12 is 360. So we have 360 pi. 360 pi. And when we combine the unit, we have feet per minute. Of course, if we don't want this, we can convert that to a feet per second. But 360 pi is equivalent to 360 pi is 1,130,197 feet per minute. Usually, if we have feet over second, in that case, we use another conversion factor. 1 minute is equal to 60 seconds. Yeah, so usually in physics, actually, when we write second, we don't need to write SEC, but because we have the S as the arc length here, I don't want to be confused with S as the arc length, so I have to spell out the second, even though in physics, a second is just abbreviated by letter S. Right, once again, we don't want minute, so we have to put the minute where it will cancel with this minute. So I have to put minute on the top, because in that case, that minute we cancel with this minute. And if we put the minute on the top, we have to put 60 seconds at the bottom. And then we do the math. That divided by 60. And we have 18.85 feet per second. Right. Like I said, usually the unit will be meter per second or feet per second. It is more standard that way. Right. So, like I said, in this section, we have angular speed and linear speed related by this formula, and that's all we have. Right. Next, look at another example. A water wheel has a diameter of 16 feet. Assume that the wheel makes 12 revolutions per minute. So once again, we are given the angular speed in the RPM, revolution per minute. Find the speed of the river. Assume that a point on the outer edge of the wheel move at the same rate as the river and is 8 feet from the center of the water wheel. So first, let's draw the water wheel, and it is a circle because it is the wheel. So we draw a circle here. Close enough. By the way, if you want to draw a circle, the trick to that is hold very steady like this. So don't move the hand, so the hand is fixed, hand steady. One of them is center, the other one is tracing to make a circle. And whatever you do, do not rotate the hand, always rotate the paper. And you will have a circle. And then there's the center, of course. Yeah, so that's a little trick of mine. Anyway, so we have the water wheel. So let's say the water wheel. Of course, in order to make it rotate, it has to have some kind of pedal. So let's draw some pedal. Right, so we have that. It's a water wheel. And then we have the river flow. So the river will be at this level, touching the water wheel. So as the river flow, it's push the paddle, and in that case, the wheel will rotate. So that's how it works as a water wheel. Right. So in this case, a wheel has the diameter of 16 feet. Assume that the wheel makes 12 revolutions per minute. That's later. And then assume that a point on the outer edge of the wheel will be right there, move at the same rate as the river. Yeah, assume that it rotated. This point will move at the same speed as the speed of the river. By the way, of course, the wheel, when we talk about in the perfect condition, it may not be like this. It is like this, but of course, the water level might be rise. It might be a bit below here, or if the water rises, it will be there. But assume that it is perfect, that the point on the wheel, the water level and everything is perfect, right on the edge of the water wheel. That's what we have to assume in this part. Right. So in this case, what we have is diameter is 16 feet, but the radius, of course, is 8 feet. And speed, angular speed, 12 revolution per minute. Once again, that is not very useful way to calculate, so we'll use 1 revolution equivalent to 2 pi radian. Cancel out the revolution. We have 12 times 2 pi is 24 pi. That will be radian per minute. So that gives us the angular speed. Next, find the speed of the river, which is the linear speed, is r times omega. The radius is 8 feet. The angular speed 24 pi radian per minute. And the radian will cancel by itself. Once again, usually it is better we write feet per second. So we write 1 minute over 60 seconds. And then we just do the math. It will be 8 times 24 pi divided by 60. 8 times 24 pi divided by 60. So we have about 10 feet per second. Because the minute cancel out. And all the numbers will be about 10 feet per second. Right, so how fast is that? Because if we cannot visualize, usually if we want to change, I can go to like meter per second is something that we can visualize, or mile per hour. Let's say if you want to change this to mile per hour, how do we do that? So just write 10 feet per second, right? Now convert to mile per hour. So how many seconds in an hour? When you said that 60 seconds in a minute, 60 minutes in an hour. So that in 1 hour, that will be 3600 seconds. I have to put like that second, so it will cancel with the second at the bottom. 1 hour will be at the bottom. Now the second will cancel out. Next, another ratio. How many feet? How many feet in a mile? And that's 5280, right? So 5280. And if you don't want feet, you put feet where it will cancel with this feet. So 5280 is 1 mile. And again, the feet and the feet cancel out, and those are all the numbers we have. So we end up about 10 feet. It's not exactly 10, it is that much. So let's use that number instead. Times 3600 divided by 5280. Did I 3600? I forgot a zero, sorry. So that gives about 6 miles per hour. 6.85. Those are all the numbers, and then we have mile per hour. Right. So pretty much this, of course, there's only one formula in this section, but most of that we just do the unit conversion. And the key for doing the unit conversion is that whatever the unit we don't want, first of all we have to write out the conversion factor, like 1 hour 3600 second, and then 1 mile is 5280 feet. So we have to know that first. And then when we put in the fraction, we put where it is cancelled out. If we don't want second anymore, we put second where it will cancel with this second. Of course, we have to put that on the top. And if we want to cancel the feet, we have to put the feet where it cancels with this feet. So it have to be at the bottom, so that will cancel out. So pretty much conversion factor, how to do that. And then just that formula is what we have in this section. So this is a very short session. As always, thank you for watching, and see you in another video in trigonometry.